from the team of University of Applied Sciences, Würzburg-Schweinfurt from Germany. The authors are Mikita, Dzemko, Bastian, Engelmann, Jürgen, Hartmann, and Jan Schmitt. The paper is entitled Towards Shifted Production Strategies Through Additive Manufacturing, a Technology and Market Review for Changing Value Chains. We are looking forward to your video presentation.
Hello and welcome to my talk. My name is Jan Schmitt. I'm with the University of Applied Science Würzburg-Schweinfurt, and the presentation is titled Towards Shifted Production Strategies Through Additive Manufacturing, a Technology and Market Review for Changing Value Chains. Here is the agenda of my talk. After a few introductory remarks, we talk about additive manufacturing technologies. Then I will present the research and technology and market review we conducted. Then we have a special look to changes in value add through different methodologies, namely the Gartner Hype Cycle, the Product Lifecycle Management view, and a view through the digital production. After this, I will conclude my talk with a small summary and research outlook. Let's start with the first 3 points of the agenda. Recently, we can see the development of additive manufacturing for different materials such as metal, plastic, or ceramic rises the stage to market maturity out of the research field. It seems to be that additive manufacturing grows into different business areas and transforms structures and processes of entire supply chains, for example. In order to have a view to this, we try to conduct a market and technology research by 83 companies which provide 339 printer models. Due to this, we try to structure technical indicators such as accuracy, working space, process speed according to the processed material classes and the additive manufacturing method. So the aim we want to reach with this paper is to have a research, technology and market review as an instrument for deriving research questions and classifying trends, for example, in the megatrend of digitization. So what have we done first? To investigate the additive manufacturing research field and market field, we structure everything in different categories where you can see the additive manufacturing principles like material extrusion, binder jetting, powder bed fusion, or direct energy deposition, for example, and the different additive manufacturing methods belong to a category, and the different materials processed by the methods are also named in the table. So in order to have a look to the additive manufacturing research field, we count the scientific publications released in order to have a research landscape over the time and see how different methods develop over the time. In order to have a research on the market field, we analyze technical data of printer models and suppliers and companies which offer different printer models in order to develop a landscape for research focus over the time and the prioritization of different additive manufacturing methods. On this slide, you can see the results of the research review by the number of publications according to the Google Scholar results to the keywords additive manufacturing and review additive manufacturing from the year 2000 with a perspective to year 2022. What you can see is a decelerating growth rate of the publications, which indicates maybe the acceptance of transfer of additive manufacturing technology from the research phase to the application phase. So the question is, do we have a saturation of additive manufacturing in the research activities? This slide contains the breakdown of the relative proportions of publications according to the different additive manufacturing methods. It can be seen that additive manufacturing technologies of metal processing have a very high ratio. I mark it here in red. Especially direct metal laser sintering, selective laser melting and electronic beam has the highest average growth rate according to the absolute number of publications with about 10 to 13% per year. So it can be considered that metal-based additive manufacturing processes are located in the application-oriented research when you take this slide and the previous slide into account. When we now switch over from the research review to the market review, we figured out the distribution of printer models according to the material groups. In the table below, you can see the number of printer models and the number of companies which offer these printer models regarding the processed material. And especially in the plastic processing part, a lot of printers are offered in the market by a high number of companies. Metal, which is more or less suitable for the mostly for the industrial purpose, is represented by 17 companies and nearly 60 different printer models. Other material processing technologies are less represented. So it can be stated that we have a very high proportion with regard to plastics processing, which is highly integrated in the hobby branch, whereas especially the metal processing is integrated in the industrial application. When we now take this into account and we consider the regional spread, it can be seen that only highly developed industrial nations offer 3D or additive manufacturing technology. When you consider the metal 3D printing technology, only Germany, Netherlands, and the east side of the USA more or less offer all models of metal 3D printing, whereas 8 from 7 companies are located in Germany. When we now switch over from the market review to the technology review, we considered in this presentation, in the paper more, but in this presentation, two main criteria, the working space and the layer thickness. Here you can see the results of the working space evaluation. The working space of an additive manufacturing printer is normally a decisive criterion for its application in various industries because it determines the maximum component size. In this table here you have the materials, here the material classes, and here we have the printer technologies such as powder bed fusion, for example, and in total it can be seen that we have high differences between technologies and materials, and a very high working space can be realized by material extrusion processes. Here for plastic, here for metal, or here for composite processing, for example. So this is more or less the first insight to the machine selection. When we now take the layer thickness into account, the layer thickness is an indirect criterion for accuracy, and in the scientific literature it is considered questionable and discussed because many factors influence the accuracy. It's first the resolution of the pressure head, the material, the location or topology of the component which are placed in the workspace, and the pre and post treatment, and especially a high influence on the accuracy has the stack factor or the staircase effect. So the layer thickness is the parameter which is mostly named in the data sheets, and here we also structured this according to the material and the different additive manufacturing technology. So here it can be stated that we have a very low span of the, except binder jetting of course, a very low span of layer thicknesses, and especially the metal processing additive manufacturing technologies can be printed in very high resolution. Here we can identify research topics due to the many factors which influence the accuracy, and the only parameter which is named in the data sheets most of the time. So very good research topic can be the process structure property relationships of the different additive manufacturing technologies. Now we close up the first part of the presentation, and now after this insight into technology, market and research, we will have a closer look what changes in the value chain according to this breakthrough technology of additive manufacturing. This is done by different scientific methods, the Gartner Hype Cycle, the product life cycle view, and the view of the digital production. The first view to the change in value adding chain is made by the Gartner hype cycle, which is very well known and has five phases from the first idea to the market commercialization, which is done in stage 5. We have different views. We have first the technological view and then the application-oriented view, and we evaluated the years 2015, 2017, and 2019. First, it can be stated that the plastic processing processes have a very high market penetration. You can see it here on the blue arrows, but more interesting is the application-oriented view. Here it can be seen that consumer 3D printing is more or less established in the market, and you can also see it as a private person that you can buy 3D printers for very low money. In the industrial application, it can be seen that industrial 3D printing disappears as a term in the Gartner hype cycle, but it's replaced by operations. So 3D printing and manufacturing operation, and it progressed until the phase 3, which is meant disillusion. So it can be stated that maybe the applied research can make a major contribution to transfer this additive manufacturing technology, especially for industrial applications, from the phase 3 maybe to the phase 4 and phase 5. A second approach to have a closer view to the changes in the value-adding chain is the product lifecycle view, which is a holistic view to the life cycle which addresses the increasingly complex and dynamic business environment. It's also time-based, and you can see the curves and turnover and costs and investment due to different phases of a product or a process: an innovation phase, the introduction phase, the growth phase, the maturity phase, and the declining phase. For companies which want to place themselves in additive manufacturing, you have different options for actions, which can be product-oriented here in green, process or production-oriented in blue, or business segment-oriented here in violet. As an example, in the innovation phase and with product-related, people or companies can decide that they want to decrease weight of their product by additive manufacturing, or in the manufacturing phase, in the introductory phase of a product, you can use additive manufacturing for doing efficient and fast tooling, or in the business-oriented segment, in the phasing out time, you can develop a spare part strategy which is based on additive manufacturing, or in the growth or maturity phase, you can minimize your inventory by producing customer parts by additive manufacturing. So you can see with this approach that there are high potentials in additive manufacturing technology in all the life cycle phases. And companies should have a strategy for the economic use of additive manufacturing technologies, which is unavoidable. The third part I want to talk about is the digital production, which also has a high contribution to changes in value-adding chains, and this has to be combined with the additive manufacturing technology. So it's the trend of digitalization in production, which is also related to a vertical integration of necessary processes. The aim is to establish a consistent digital engineering chain from the CAD design to a quality assured part, and the aim is to have total process transparency and optimize everything within this value chain by data, and the data you can derive from the CAD design, from simulation, from the slicing, because for additive manufacturing you have to slice the part according to the layers. Then you have to schedule your work, to set up the machine, and last but not least to print the materials. And this is from the virtual world to the real world, and back in a closed loop, because the aim is to have a process transparency, and you need the experiences from the printing, the machine setup, and the slicing to optimize your part in the CAD design, for example. This is also a very high topic to do research on. So you have a huge research field, especially in model preparation and recording and or the feedback of the data, because in the printing phase a huge amount of data comes through, which carries out a good information about the process. Let me now summarize my talk and give a short outlook. As a starting point, we see the need for a market and technological overview of additive manufacturing processes according to different processed materials. Therefore, we prepare the data of many manufacturers and printer models in order to derive key figures that can also be used for the systematic selection of additive manufacturing procedures. We take this into account due to different scientifically established models for the implementation of technologies and their use in the product life cycle, and also have a view to the digitization as an enabler for economic use. So thank you for your attention, and if you have any questions, I will be there on the Skype chat. Thank you.
Thank you for sending us this presentation. We are going to have a Skype call with the presenting author Jan Schmitt in a second. For those of you who has just turned in during the presentation, we are live on live stream 2 of the 7th CIRP Global Web Conference. Today is the second day of the conference, and we are on the paper session with 5 papers about the topics regarding additive, coating, hybrid and incremental manufacturing. We have been just listening to the paper entitled Toward Shifted Production Strategies Through Additive Manufacturing, a Technology and Market Review for Changing Value Chains. This contribution reached us from the University of Applied Sciences, Würzburg-Schweinfurt, and the presenting author was Jan Schmitt. There are basically 2 questions to the author, which I'm gonna read from our commenters. The first one asks, to what extent data models and production software systems dominate the additive manufacturing market? So I'm turning back to Jan Schmitt. Jan, can you hear us? Jan, can you hear us?
I can hear you. Can you repeat the question, please?
Yeah, sure. The question is, to what extent data models and production software systems dominate the additive manufacturing market?
I think there is no special answer. You have to distinguish of the pre-processing of the additive manufacturing process, the processing itself, and the post-processing. I think in the pre-processing, the slicing softwares are the most relevant. For example, Slicer, and the data you put in is a standard STL file, for example.
Okay.
So Slicers are very, and in the processing itself, here more or less every additive manufacturing machine producer has its own software solution.
So if, I mean, that's also our experience that there are multiple specific solutions. When you deal it from with different software solutions from the research perspective, what are the challenges you face?
The challenges, of course, is the continuous and the holistic software chain, the engineering chain from the CAD model to the produced part. Yeah, to have interfaces, standard interfaces, or an entire software solution which covers all challenges within this engineering chain, from the CAD, to the slicing, then to the preparation of the process and the process steering control itself.
Thank you for your answer. Could you also say a few words about the research project you have funded this work for?
So this work, it's a special kind of a project in Bavaria with the metal producing companies, and it's public funded from the state of Bavaria, and it was just the start point start point, we want to create a landscape of technologies and products which can be produced by especially small and medium companies with additive manufacturing in order to bring together the requirements of companies, the machine builders, and the requirements of the process in one hand. And this is the start point to have a research. What are the performance of the different processes in additive manufacturing, and with a special focus on metal processing.
Okay, thank you for your answer. You are saying it is a starting point, so what are the upcoming steps?
The upcoming steps is that we have in this field of companies, we have special companies, and there we want to cluster the products they have, and then we want to find out what are the special requirements of these products and what abilities or what can be produced by additive manufacturing processes. What products can be produced in a totally additive manufacturing process or in a hybrid processing. Mm-hmm. This will be the next steps. So the clustering of the products and bring them together with the abilities of the additive manufacturing processes.
Mm-hmm. And what are the boundaries you see at the moment for additive manufacturing, from also from the industrial perspective?
The industrial perspective, I see the investment costs for the machine.
Okay.
Because companies have to calculate when the machine is paid back, and this is quite expensive if they do not know what is the real ability of such a machine. It costs about 1 million for metal processing, and this is quite expensive, and they do not know yet what the ability of such a machine is regarding to their product portfolio.
Okay, thank you for your answer. And could you just also specify your role within this complex and innovative environment?
Yeah, my first role was that we conduct this market and technology review, and afterwards my role is that I have the process view, so to bring all the disciplines together to develop the result which is useful for the companies and for the research on both sides. So I have the process overview, hopefully.
Good luck with it. Thank you for your contribution and your time. Hope to see you again.
Yeah, thank you.
Bye.
Bye.